We have Caroline Smith Fix. She's head of research sciences collections at the Natural History Museum in London. Okay, so news from Mars, not just that water was there perhaps millions of years ago, but also these organic compounds. Can you explain the importance of that discovery and how much more likely, if you believe so, that makes it that there was life on Mars at some time?
Yeah, of course. So what we found with data that's come back from the rover and has been studied over the last few months is that we see igneous rocks. So these are rocks that have been formed through volcanic processes, which have also been affected by the action of liquid water. And that's really, really interesting and exciting because liquid water is one of the key ingredients you need for life to start. So if you've got the chances of life ever being on Mars, you'd need to have somewhere that had liquid water for at least a period of time. And we've got good evidence for that. Now that's combined with the fact that we're seeing, using instruments like Sherlock, which is an instrument that I'm involved with, also the presence of organic molecules. And organic molecules are chemical molecules made of the elements carbon, hydrogen, oxygen, nitrogen, sometimes with some sulfur, sometimes with some phosphorus, and maybe some added other things. And those are really, really important because you need organic molecules for life to start. And the other thing that's really interesting about organic molecules is they can actually be fossil evidence, sort of fossil chemical evidence of potential past life. Now, it's very important to say that the organic molecules we found so far, we cannot conclusively say or even guess that those are evidence of past life. To be able to do those types of experiments, we'd need to do really detailed experiments on labs, in labs on Earth, which we hope to do in the 2030s, when we hope that these samples will be returned from Mars. But with more evidence coming from Perseverance, we're seeing some really interesting scientific results, very, very tantalizing.
So, and that's another remarkable feature of this mission is that those samples, they're going to be put on a tiny little rocket and sent back to Earth. I mean, how much of a difference will it make to have those samples in hand? Can you determine conclusively once you have that stuff in a lab back here on Earth?
Yes, that's exactly what we hope to be able to do. So Perseverance has got some amazing scientific kit on it, but you cannot miniaturize some of the instruments and the techniques that you need to do conclusive life detection experiments and evidence for actually the chemical signatures of past life. Those have to be done in labs on Earth. And so that's why we're so excited to get these samples back.
Would it make a difference, because there's a lot of excitement, understandably, about putting men and women on Mars, perhaps in the next several years, both private and government plans to do so. Would it make a difference to have a person on Mars who could look in different places than a rover can?
Yeah, that's a good question. And there's actually a lot of debate about who makes the best explorers. Is it amazing robotic explorers like Perseverance that has X-ray vision in some ways and has all of these amazing chemical techniques it can use? But at the end of the day, I'm a great believer in that, you know, humans, we have inbuilt curiosity. We can make decisions very, very quickly. We have a high degree of autonomy, much more than the current rovers, even though they're fantastic. So I think that, you know, to really push those frontiers of exploration for the moon and for Mars and potentially elsewhere in the solar system, I think we would always want to have human astronauts going to those places.
Fair enough. Good. So you and I can still get our trip to space. Caroline Smith, thanks so much. Thanks so much for joining us.
My pleasure. Thank you, Jim.